So we would be looking at the problem 91 in leetcode, that is decode ways. And in this problem, it states that there is a message that is encoded with numbers uh, 1 to 26. Now these are not numbers but Unicode characters, like 1 as in string 1, 2 as in string 2, similarly 26. And each of those characters from A to Z is equivalently encoded like this. And we have to find the total number of ways we can decode this message. Now take an example of this particular message 11106, and the total number of ways we can decode it is either with 1, 1, 1, 0, 6 or 11, 10, 6. These are the two ways. And similarly we have to find all those messages, all those numbers of ways we can decode a particular message given the encoded format is provided like this. Now question may come, why can we not decode it like 11, 10, 6, sorry 11, let's forget this, let's say it's 11, 1 and 0, 6. The reason is that since each of those characters is represented by the string format of the numbers and there is nothing 0, 6 to represent it, we cannot match that, and so anything that is starting with 0 would be invalid as a decode format. So we cannot take 0, 6, and that is all that is the problem actually describes. So we would be looking as an evolving way of solving this problem. That is, I would be first taking into the brute force approach, and then similarly moving on to the memoization approach, and we would be then trying the down to up, that is bottom up dynamic programming. And so yeah, let's get started. Let's consider the following 1, 2, 0, 1, 2, 3, and let's figure out how many ways can a particular message be decoded. Now since a number can represent a character from A to Z, so either a number can be 1 or it can be double digit. Either it is a single digit or a double digit. So every time we would be taking on the decision path, either we would crack the number as a single digit number, or we would make the number as a double digit number by adding the neighboring characters, and similarly we would continue from that path onwards, right? And so for this example, it would be once we started our decision, it would be 1 or 12, right? So if we are to provide with only this part, so either it is 1 or it is 12. Now from 1, what can we get is that either we can get 0 or 0, 1. Now we already know something that is preceding, that has a 0 preceding cannot be considered, right? So this path is obviously wrong. So yeah, so after 1 we can either have 2 or 20, and after 2, now this is the scenario that I was saying, 0 or 0, 1. So we cannot proceed with this path, we have to continue from here. So after 20 there can be either 1 or 12, right? Here either it is 1 or we are considering 2 to be conjoined with 1 to provide us the decoded message. So either it is 1 or 12. So if it is 1, what is the next decoded string the next string could be 2 or 23. If it is 2, the next could be 3 or 34. Now 34 is not possible because we only have 26 characters, so we cannot proceed in this path. So after 3 there will only be 4. Similarly for 23 we can either have 3, and similarly on the other side there is 34, which is not possible, and there is only 4. Now let's get back to this 12. After 12 we can have again 3 and 34, which is not possible, so after 3 and 4. So for this particular number 1, 2, 0, 1, 2, 3, 4, there are these 3 ways that we could decode this string. Say this decoded string can be of these 3 formats, that is 120, 1, 2, 3, 4, this one, or 120, 123, I made some mistake. So 120, 123, okay, I added extra 4, yes, 4, and similarly 120, 12, 3, 4. So these are the 3 ways that we can say this particular thing belongs. So that is 1, 20, 1, 2, 3, 4. The other is 1, 20, 1, 23, 4, and another one is 1, 20, 12, 3, 4, right? So one particular thing that we have to remember is that we cannot continue a path if there is a 0 in it, and similarly we cannot continue a path if the value that is being provided is being greater than 26. And let's get on to our brute force method, and let's create a depth first search with a particular position. And what we are going to do is count the number of, so for each, we know that for each particular point there are 2 decisions, right? So like we explained, so there would definitely be 2 calls of depth first search. Now we have to figure out like what we are achieving in this thing. So every call would be returning us a count that is of like the number of paths that has a valid way. So similarly for this also we would be having something, and at the end of the day we will be returning the count. So every time we are calling, so we would be initializing the count with like the first call, if it is reached the particular side, say for example this one, so the count will be 1, and then it reaches here, so the count will be 2. So for 1 there would be two distinct paths to go by, right? So we are actually calculating how many number of paths can a particular point provide a decision. So that is what I am counting. And now what will be passed on to the DP for, so either it is pos plus 1 or it is pos plus 2, right? Pos, when are we going to like send the next position is that when there is nothing to with 0, right? So in either case, if there is a 0, we are not going to proceed. So either we are going to pass the next position, or we are going to assume the next two positions has something that is less than 26 and going to pass the next position, and we are going to check if it is reached the bottom. So if position has reached to that bottom, we are going to return 1, and that is it. Just we have to check, like, if this position is not 0, then only continue with this calls, and we are going to go for this next position, that is only if the integer value of this position is less than 26, then only we are going to count this thing. And also to remember, like, the pause shouldn't be, I mean, length of, if we have reached to that end of the I mean string, there is no point in recounting, right? So yes, that is all. Now let us run. Okay, I'm not calling. My bad. Okay, cool. Now we can see that we have a solution that runs, but if we are going to submit it, we are going to get a like a TLE, because obviously the time solution of this is 2 to the power of n, where n is the length of the string. And so this, for this kind of input where the string length is high, 2 to the power this, it is going to throw us an error. So time limit exceeded. Now what we are going to do to bring it within a time limit is we are going to cache the solution. Now if you remember, we know like how many paths could there be after a particular point of time. So for this 2, there could be either 3 and 4, or there could be 34. And now if you are going to come to this particular point in the next example, we might not have this, but okay, so there was supposed to be 12, 3, 4, 2, 3, 4. Okay, cool. So we can build some examples, but anyways, at this particular point, we know like if we are reaching to this particular position, we'll have two ways to divide this number. For example, 1, 2, 0, 1, 2, 3, 4. This last digit 4, how many ways can we represent 4? 1, right? Because there is only one. But if we are going to consider these two, how many ways can we represent them? That is 2, because that could either be 3 or 4, or it could be 34. Now for this path 2, 2 is going to either give us 3, 4, or 34, like over here 3, 4, 34. Similarly, for 12 we had a 3 and 4, and on another side there should have been this 34, right? But since 34 is not a valid string, we are only to consider the path next to it is 1. So this thing 3 and 4 can have two output. It's not true because 34 is greater than 26, so it is 1. So once we have reached to this position, we know that there is only one way we can represent the next position. And similarly, if we add to that, once we come here, and we don't have to, again after 1 we don't have to keep recalculating till the end, right? If we know how many ways that a particular position can represent, I mean how many ways how many ways the decision tree can lead, and what is the, from here let's say we come to this particular position, and from here there are 3 ways we can reach to that end. So after, so once when we are building a decision like this, and from here if it is going to come here, we don't again have to recalculate this whole path, since we know there are 3 ways to this. Once we come near to this, we are going to directly send back 3 to the previous node, right? And all we need to do is now cache the count, that is we will create a DP, and we will just say how many ways we can actually get a particular decision at a particular point, how many ways we can reach uh, that point. We are going to create a hash map, let's say it is DP, and for every position in that hash map we are going to store how many ways we can represent a particular decoded message. And if that position is already present in the hash map, we are just going to return that DP of that position, right? So yes, let's run this, and we have our first top-down approach. Now let's get to that bottom up. The bottom up is also the same, and in this case we are going to represent with the length of the string, and what is our base case? So the best case is that, let's assume okay, let's get on here. So for this number 1 2 0 1 2 3 4, how many ways can 4 be represented as in 1, right? How many ways can 3 be represented in? That is 1. So either we are going to continue with the value of the previous number, or let's say if it was 2, then we are going to add 1 to that previous number and say 2, right? So what we can say, since we are carrying forward the value of the previous, we can say our base is 1. So when we encountered the last digit, we are just going to carry forward the value. Now after that, when we are going to encounter the second last, we are either going to add 1, we are going to carry forward the value of the second last plus the value of the last. Similarly for this, we are going to carry on the value of this plus this, that is 3 if this was 24, right? But if it is 3, then obviously this is 1, we are not going to carry forward. So it is actually representation of our Fibonacci series, that is 1 1 2 3, similarly 5. But what we have to remember is that if it is 0, we are going to represent it as 0, and similarly continue doing it. And the thing with our TP is with our bottom up approach is that it is totally present over here. All we need to do is just copy this. Okay, let's just write the loop. And again, if s, we are going to next position, and similarly if the position is, or we can say position plus 2 has become greater than length of dp. Let's first write what we are trying to. Right, then what is the pos? Pos is okay, and we won't have pos plus 2 if this thing exceeds. So similarly, if pos plus 2 is greater than or equal to length of dp, sorry, right. So if it is only in the range, then we are going to add that thing, and let's just omit. Now if you can see, like this, I mean, once we have our top down memorization and we know what we are caching, it is the same as in bottom up approach. All that we did was create a best case scenario for this, that is one, and let's run the solution. Sorry. Okay, my bad. Cool. So that's it, guys. This would be our bottom up approach. So if we can now once more review it, what, how are we going to approach the problem is that we are first going to build the brute force solution, and once we have built the brute force solution, if we can find our caching position, that is voila, we would have a top down memorization. And from this top down memorization, we can see there are two positions getting added, either it is position plus 1 or position plus 2, same as in the Fibonacci numbers. And we are just going to do the same with the bottom up. All we need to do is create the best condition, and that is it. So yeah, I'm going to just delete this portion, and yeah, cool. So thanks a lot, guys. See you in the next video.